In the name of Allah, today we are explaining block ciphers and the data encryption standards. The first method to encrypt some text is or was known as Substitution Cipher. In fact, it is one of the very old methods to encrypt a text. In this case, this method has been implemented in the Second War worldwide, and the method was something like that. Consider that each letter in the alphabet is replaced by another letter. We called it as shifting. For instance, there is a method which called as Caesar's cipher, which in this method each letter of alphabet is shifted by 3, as you can see in this table. For instance, A must be substituted by D, B by E, C by F, and etc. Hence, having a plain text like this one, which yield a cipher text with Caesar's cipher text or Caesar's method, as you can see here. In fact, this method is so simple and could be used by any number. I mean, for instance, in Caesar's cipher, we used number 3, but it is not essential to use anytime the same number. It could be used by any shift from 1 to 26, the total number of English letters. And as you can see here, encryption key is a mapping from set of 26 letter to set of another 26 letter, as you can see here. Hence, using this kind of monoalphabetic cipher substitute, which this plain text Bob, I love you, Alice, the cipher text is this text that you can see here. Okay. Hence, you can see that this method relies on the secrecy of the key. Okay. The total size of our keys are 26 in English. Hence, the total space for the secret key is relatively too small and can be calculated. Here you have in English letter, the size of key is equal to, for instance, 26. Hence, there are 26 factorial. Sorry. Factorial, which is equal to 2 power 116, which is quite small and can be calculated easily. Hence, this method is not secure. Anyway, you may ask, okay, why this method is not secure? Before explaining this, please take a look to this table. I will try to. Okay. This said that in brute force attack, the space of your key is so important. Here in this table, you can see some example. For instance, for key size of 22 bits, the number of alternative keys are 2 power 32. Okay, and consider that for each computation we need, for decryption, we need 1 millisecond. Hence, in order to break this kind of cryptography, we need a time equal to 65 minutes. And consider that with the more power systems like today's systems, if the system can do 10 power 6 computation in each millisecond, hence this crypto system can be broken only in 2 milliseconds, very short time. And continuing this approach, you can see by increasing the key size, the time required for breaking the encryption scheme is increasing as well. And for instance, for a key size of 128, with the today's systems, we need something like that time, 10 power 18 years, which means that it is secure enough. And when we increase the key size, we can see that the time for breaking this crypto system is increased very sharply. Okay, hence it is so important to choose an appropriate key size for your encryption scheme. Key size or key space, they are the same. Okay, hence the time that is needed for breaking a crypto system is proportional to size of key space, as you can see is this table. Okay. There are several classical ciphers, as we said in the previous slides. The first one was Substitution Cipher. We have also Permutation Cipher that we explain just right now. Okay? Here in this slide you can see the Cipher cipher in more detail. I will try to put this slide for your reading if you need. And as you can see here, mathematically, Cipher cipher method can be written in this form, as you can see here. The cipher text is encrypted by the key, which means that you need to shift your plain text, your letter, by the key K. And for decryption, you need to do the inverse. See your cipher text minus K. K is your secret key. Hence, you can get your plain text. Okay? Note that this method can be used for any alphabet. Okay? Anyway, as we said, the key space for this method consists of only 26, and Cipher cipher is vulnerable to brute force attacks. Okay? Okay, but how Cipher cipher can be broken? Or in the other word, how we can find the secret key? There are some contexts that are so important. The first one, you know that any language, any human language, is not random. What does it mean? It means that normally letters are not equally frequently used. For instance, in English, letter E is the most common letter that is used, and the other letters are T, R, N, etc. Okay? And the other letters, like for instance Q and X, are rarely used. There are also some tables for single or double or triple letter frequencies for any language. This table can be used for brute force attacks. For instance, as you can see here you can see English letter frequencies. As you can see, letter E here is the most frequent letter in English. And after that, the next letter is T, and so on. Hence, doing some statistical analysis our ciphertext, an attacker can easily find the secret key.